I'll
So
move.
moved. Second.
Okay. Ken moved. Is there a second?
Second.
Grace seconded. All in favor of approval?
Aye.
Aye.
Opposed? So minutes are approved. Okay, the first item of business is a presentation by Todd Studenbeck. And due to we have a lengthy agenda and time constraints, so I'm only going to accept comments from the committee and from the staff for this topic. Would you like to introduce the topic and the speaker, Eric?
Yeah, so this is discussing a preliminary round of environmental sampling that USGS did out at the airport. They did this on behalf of the town of Middleton. And this is the same presentation that Todd and Laura Schachter, I think, right, Todd?
Correct.
Made to
Laura's with me
town
tonight.
in December. I think, well, that's all I'll say about it. I think, Todd, you can just take it away.
Sure. If you want to just give me the ability to share my screen, I can
Oh, boy.
rock away.
Meantime, hi Todd, how you doing?
We miss you, Warren. You got to come down more.
Yeah, I wish I was. Things at home aren't going that well. I can't do it.
Sorry to hear that. How you doing, Eric?
I'm okay, Todd. How are you?
Good. It says my host disabled participant screen sharing for now.
Yeah, I have the same message.
How about now?
Cannot start screen share while the other participant is sharing. So somebody needs to unshare apparently.
I'm now unshared.
There we go. We're getting there. I just got to figure out which screen we're on here. Okay. I think that should do it. All right. Well, good evening, everybody. Eric introduced me, Todd Studenbeck. I also have Laura Schachter on with me. Laura has been my co-PI on this brief investigation to your neighbors to the west out there. And as Eric said, tonight we'll be presenting a preliminary analysis of a small subsection of the data we collected in 2022 for the Maury Airport study. So in total, we collected more than 75 samples on and around the airport, and we have nearly 2,500 concentrations from over 40 different analytes. So there's not nearly enough time to go into detail on everything tonight. So we'll do our best to cover, what we think you might find most interesting. I believe there's a copy of the presentation in the agenda, and Laura and I will also be working on a report for this data this year. This was initially slated to be a 3-year project, but it looks like we're just going to call it a day and move on to the report phase sometime later this year. All right, so the town of Middleton approached Warren first, and then Warren got a hold of me regarding potential contamination of soils, groundwater, and surface water resources due to activities at the airport. And the primary concerns were the fireworks launched as part of the Rock the Ramp effort in July of 2021, and also the aircraft and the ground support equipment and activities necessary to maintain and fuel the aircraft. And for fireworks, a few analytes of concern. Perchlorate was number one, and the metals that are launched in fireworks was another concern. Perchlorate is an oxidizer that's mainly used in rocket fuel, but you can also find it in fireworks. It makes them go bang. And you can also find it in certain fertilizers from around the world, the inorganic fertilizers. And of course, various metals are used to impart color in fireworks. And then from an aircraft activities perspective, the big concern was the leaded aviation fuel, the Avgas 100 LL used in the piston-driven aircraft flown there. We were also looking for BTEX, benzene, toluene, ethylbenzene, and xylene, and GRO, gasoline range organics. There are chemicals found in fuels and oils and degreasers and paint thinners and so forth, things that you might find in equipment that is supporting aircraft flying in and out of the airport. So many of these analytes we're looking for can have ecosystem or human health impacts at high enough or sustained concentrations. So thus the concern from the town of Middleton. And our objectives were basically to measure concentrations and try to identify potential sources of perchlorate, selected metals, BTEX and GRO in the water resources and soils near and around the airport, and on the airport, I should say. And so we collected samples of surface water, both during an active overland runoff event and during low flow or base flow conditions. I also collected samples in groundwater, in private drinking water homeowner wells, and in shallow pore water, and also in the soils on and around the airport. And we borrowed some of the study design and sample analyte lists from a prior USGS study, 2016 USGS publication looking at metals and perchlorate from fireworks launched at Mount Rushmore over a period of years. So if you have interested in this topic, that's a good paper to turn to. So as I mentioned, the metals in fireworks impart the color when they're ignited, and we're lucky enough to have the Wisconsin State Lab of Hygiene here in Madison, and they happen to have a 26 element metals panel that includes nearly all of the metals shown here in yellow. And the ones in yellow are the ones most commonly associated with fireworks. We added lithium to the 26 element panel because it was also in the Mount Rushmore study. Just keep in mind that the panel that we ran is considered screening level or qualitative analysis, which means that the instrumentation is quite sensitive, but you can't get as precise as a low level, say a trace metal type analysis, which is significantly more expensive. And concentrations of perchlorate were measured at RTI, which is a USGS contract laboratory in Michigan, and they have a sister company in Florida. So we're fortunate to have that lab nearby, and it turns out that they have a pretty expensive, very sensitive instrument that can do very low levels of lead concentrations. So we opted to do these analysis on selected samples along with an isotopic analysis. And there are stable non-radioactive isotopes of lead that can help determine the likely sources of lead out there. And Laura will describe this in a little bit of detail in just a bit. So I already mentioned BTEX and GRO. And now I'll turn it over to Laura to talk about the private drinking water wells.
Great. Thanks, Todd. You can hear me, right?
Yep.
Okay, great. So we sampled a total of 12 private drinking water wells, with 2 of those wells being up gradient from airport property and 10 of those wells being more down gradient, specifically in the Highwood Circle neighborhood in the town of Middleton. These wells were sampled on either May 31st or June 1st, 2022. And we collected our samples from outdoor faucets, and all the homeowners responded prior to us going out to collect our samples that their water supply to their outdoor faucet, to the best of their knowledge, was untreated. And we wanted untreated well water for this study in order to characterize the groundwater aquifer. Those results were sent out to the participating homeowners just a couple days after our meeting with the town in late December. So from regional groundwater models and monitoring, we know that groundwater generally is flowing from the northwest to the southeast towards Lake Mendota in this part of Dane County. And so those up gradient homes that we sampled that are in that larger yellow circle that Todd's pointing to shouldn't have chemicals in their groundwater that are sourced from activities on airport land, such as the 2021 fireworks. This map just shows the general location of those 10 homes in the Highwood Circle neighborhood, and then the 2 other homes that are up gradient in that larger circle. For privacy reasons, the wells are not exactly located on this map. And then you can also see the airport and the runway and the approximate location of those 2021 fireworks. So the Highwood Circle neighborhood is up on a hill, And the depth to groundwater there is between 50 and 100 feet within the neighborhood. The two homes that we sampled up gradient of the airport have depths to groundwater a bit shallower, less than 50 feet. But because of that higher elevation of the Highwood Circle neighborhood, we concluded that this is likely the same groundwater surface that we're sampling from at all 12 locations. And so we expected relatively similar chemical properties among all the drinking water wells. And so, like Todd mentioned, we were sampling for some volatile compounds, those GRO and BTEX compounds. And we were, as Todd mentioned, requesting low-level detection methods for the lead isotopes. We used fresh, clean tubing at every house and every sampling location, as well as clean gloves and a clean new sample chamber that you can see my hands are in that center picture there. We also used a clean hands, dirty hands protocol. So at least one of the field crew had clean hands and was wearing clean gloves the entire time, whereas the other member of the team was sort of handling dirty things. And we just turned on the outdoor faucet at each of these homes and ran the water through a YSI water quality meter. Yep, thanks for pointing that out, Todd. And that provides real-time temperature, pH, oxygen, conductivity, and turbidity data. And so at each site, we waited for all those parameters to stabilize before we collected our water samples for this analysis. So that gave us reasonable assurance that we were measuring representative fresh groundwater at each site. So we have several of these bar charts of sample results throughout the slide. So I'll just quickly walk through how they're set up. MW1 through MW10 are the Highwood Circle homes with the numbers just randomized, not corresponding to address at all. And then MWS and MWZ are the two homes up gradient from the airport to the north and west respectively. So we can see from these plots that houses 6 and 8 in Highwood Circle have almost no calcium or magnesium, which is, as you know, what makes water hard, and relatively high sodium, which is used in the water softening process. So we can pretty safely conclude that these two homes appear to soften their water before the outdoor tap. All right, and then we can see from these plots that we did find nitrate in some of these wells in their outdoor taps, and a few of them were above the EPA and Wisconsin maximum contaminant level, or MCL, which on these plots is denoted by that red line and labeled as enforcement limit. So this indicates that the water in these homes feeding to their outdoor faucet is likely not being treated for nitrate, yet several other wells show that they are below the detection limit, indicating that they are likely treated. As you know, this area is surrounded by quite a bit of agricultural land, so having less than detection limit of nitrate is unlikely to happen unless a well is treated. And then we also have arsenic showing up in a few of these wells, which is a known contaminant in local groundwater aquifers and can become elevated when aquifers are depleted and oxygenated. So just to highlight a few wells, house 6 seems to have nitrate in it, so it's softened but not otherwise treated. House 8 was softened but has arsenic, so that indicates that the treatment system is not removing all metals. And so our results from here on out, as you can see, will be a mix of homeowner wells that are untreated and some that are treated. Even though, like I said, we asked, all the homeowners said that their outdoor taps were untreated to the best of their knowledge. So this was the best that we could do
Laura,
at the time.
Laura, how do you treat for nitrate?
Generally reverse osmosis, but I think there's more than one way to do it. But I think the most common for our homes like these would be a reverse osmosis system.
Right, I agree. I just can't imagine reverse osmosis being used for an outdoor tap.
Correct. I would think that you would want to put it under your sink that you drink from, or you're not. I mean, that means they're like showering with water that's been treated. I agree.
So I kind of question whether some homes have nitrate and others don't, because I can't imagine any of those are really treated for nitrates.
That's a good point. Yeah. So you can see that we pulled out a few of the metals that are commonly found in fireworks. Here we pulled out strontium and barium, and they exist in the environment at low concentrations. They were found both in the Highwood Circle wells and in the upgradient wells. The two homes that we suspect soften their water before their outdoor tap show no strontium or barium or below detection limit. So these metals seem to be removed with that same process that's removing the calcium and magnesium. These two wells also had the lowest concentration of potassium, which is another fireworks component, but also exists in the environment at low levels. You can see the home that we tested with the highest potassium concentration was one of the homes upgradient of the airport. And we did find some perchlorate in these drinking water wells. We had one home in Highwood Circle neighborhood that had perchlorate above the Wisconsin MCL, which is currently set to 1 microgram per liter. And we do not know currently the source of this perchlorate. One of the upgradient homes also had detectable perchlorate, indicating that fireworks are not necessarily the only source of perchlorate in wells in this area. And you'll notice that several of these were below the detection limit as well. All right, so sort of a summary. In terms of drinking water standards, the only constituents that were above either the EPA or the Wisconsin MCL were those 4 nitrate samples, 1 arsenic, and 1 perchlorate. And we found no detectable gasoline range organics or VTEX chemicals, but we did have some lower hits on some other constituents. All right, so on to the lead isotopes. So all the lead concentrations in these drinking water wells were not only below enforcement limits, but also below detection limits for that general metals panel. Like Todd said, it's sort of used as a screening panel. But we sent a subset of samples to be analyzed for trace levels and for lead isotopes. So that can detect really low concentrations. And the isotopes can help pinpoint the fingerprint or source of the lead. With this secondary analysis, all of our drinking water samples again showed that they were below that MCL, but they did have some lead present in the water, with concentrations ranging from 0.043 micrograms per liter to 0.9 micrograms per liter, like up to 350 times below the enforceable limit of which is 15 micrograms per liter. As many of you know, in the environment, elements have multiple isotopes or different weights of the same element. And those different weights of an element, such as lead, exist in different ratios throughout our environment, such as rain, rocks, plants, etc. And then we can use those ratios of specifically these lead isotopes within our water samples to help understand the possible environmental sources of the lead. All right, so now we're going to show sort of a blank plot before we put our results on it. And so in this plot, we have the x-axis showing the ratio of lead 207 to lead 206. Then the y-axis has the ratio of lead 208 to lead 206. And the different symbols on here represent different environmental sources of lead. The black X's are Wisconsin galena ore, which has been over the years made into a number of products, including lead shot, lead paint, lead tire weights, and lead pipes. The gray square represents lead derived from coal fly ash and used in coal-fired power plants. The black plus represents recently collected rainfall samples from the UW Arboretum. And you can see that most of the lead found in that rainwater in Madison is likely sourced from that coal fly ash. And then the white triangle shows the lead isotope ratios of a sample of avgas 100 low-level lead aviation fuel that was collected from Moray Airport, but during a previous study, not part of this study. So now if we plot our results on that same plot against these environmental benchmarks, we see that all of our drinking water samples plot somewhere between rainwater and leaded aviation fuel. 4 of these samples had signatures very close to rainwater, 2 had signatures very close to avgas, and 1 was what appears to be a blend of the 2. And of the 2 samples with avgas signatures, 1 was in the Highwood Circle neighborhood and 1 was up gradient to the west of the airport. And these were, like I said before, very low concentrations, 0.792 micrograms per liter and 0.043 micrograms per liter. And now I'm gonna turn it back over to Todd.
Hey, Laura, I have a question on the sampling time. The fireworks occurred in July of 21,
Yes,
and the
these were,
sampling was in summer of 22.
yep, so these were in May and June of 22, correct?
So the travel time is not a problem, or how'd you factor that in?
So we were trying to sort of see what was out there. And if you were to consider the travel time, I think we probably maybe would have had to expand the range where we were looking, but we were really specifically looking at that Highwood Circle neighborhood. That was what the town of Middleton was specifically interested in. So yeah, I think if we were to expand this project, we would look into that travel time and where we think the lead was actually going, but that wasn't really a specific concern for this round.
Okay, thanks.
I got a question, Warren, also, please. This is
Sure.
Jim. Hi, Laura. The well sampling in the Highland neighborhood up on the hill, even though the groundwater surface appeared to be similar to that of the upgradient areas to the west of the airport, were the well depths themselves variable? And so were you still drawing water from different points in the groundwater aquifer in that area, in that neighborhood?
Yeah, that's a good point. We don't have well construction reports for all the wells in the Highwood Circle neighborhood, but the majority of them were between 120 and 200 feet deep with sort of open bottoms. And the 2 upgradient houses had significantly shallower wells, so they were not that deep. So we could do a more strict analysis to see with that elevation gain of the Highwood Circle homes whether this was actually the same surface or not. But that's a good point. Yeah.
Okay, thanks.
All right. That was stuff happening below the ground. I'm better with stuff that's happening on top of the ground. So I'll talk about some of the surface water monitoring that we did out there. We had 4 monitoring stations deployed for the study. First, we had an existing monitoring station here at Airport Road on Pheasant Branch Creek, which City of Middleton has been paying for since late 2011, 2012 or so. We added a new station at Ed Tallard Park over here, which is collecting samples from a small tributary to the west of the airport. We have another site here upstream of the airport at Schneider Road. And then we have a 4th site over here at a ditch that drains a portion of the east side of the airport. You can just make it out right here. Is the little ditch that comes in and feeds this particular station here. So our stations were selected to help determine the likely sources of contaminants and from fireworks and other airport activities to the best we could. This is an image of what our typical monitoring station looks like. We have electronics in there. We have an auto sampler. This auto sampler typically pumps stream water into plastic wedge-shaped containers, but due to the interactions of some of our analytes with plastic, we needed to use special glass bottles in our auto samplers for metals and for perchloride analysis. But for GRO and BTEX and our low-level lead analysis, we really couldn't use these bottles. So we hand collected a certain number of samples for GRO, BTEX, and the isotopes and low-level lead work. So we got a lot going on with the slide here, so bear with me while I describe it. The blue line on here is the water level from one of the locations from the runoff event on June 8th through June 13th of 2022. This was the resulting hydrograph from about a 1-inch rainfall event that occurred on June 8th. The units for water level are on the secondary axis over here. So the water levels went from about 1/10 of a foot at one of these sites up to about 1/2 a foot, and then kind of came down slowly again. The different symbols on the graph represent concentrations of titanium in this case. The units are on the primary y-axis over here. And our study goal was to collect 5 water samples per runoff event, some on the rising limb, some near the peak, some on the falling limb, the best we could really. And we also had a water sample out here during low flow or base flow conditions where there was no active overland runoff happening. So the water that we were seeing in the stream was basically just groundwater discharge. So the blue diamonds there represent concentrations from Schneider Road. So these are the higher concentrations you see. So this is what is coming in upstream from the airport. The squares on here that are kind of tan color are what we measured at the downstream site at Airport Road. And then the green circles here are from the tributary to the east. And the triangles here are from the Ed Tallard Conservatory Park over there to the west. So our highest concentrations of titanium that actually measured were coming in upstream of the airport. Switch over here to perchlorate. We have a little bit different story to tell here. This time, the highest concentrations are on that little tributary to the east of the airport that drains that little ditch there in closer proximity to where the fireworks were launched. And notice here that we don't have a green circle over here during base flow because there was no active flow happening in that particular ditch during those conditions. So we measured lots of different analytes in surface water. Many were below the detection level. We didn't measure any benzene, ethylbenzene, or xylene, but we did measure some gasoline range organics, and we also had some toluene, toluene over there as well. So there really are there's so many data points here, and it's really hard to kind of conclude based on where we're at with our preliminary analysis what is going on here, but I just wanted to demonstrate that we do have that information, and there did seem to be at least a relatively strong linkage between the location of the fireworks and the higher perchlorate concentrations that we measured in runoff nearly a year after the fireworks were launched.
Todd?
Yep.
That's Jim again. Hi.
Hey, Jim.
Good. Did you measure more than one runoff event, or was this the only
Nope,
runoff event?
it was the only one. Our initial study design was to measure one runoff event before the fireworks were going to happen in 2022, and then measure a couple of events after to see if there was like a decay, like if we could see a spike and then a decay. But obviously the fireworks didn't happen in 22, and so we basically just bagged it right there.
Okay.
Yeah.
Todd, this doesn't seem like a very large event. So
Right.
do you feel it's representative of runoff from the whole watershed, or just near drainage ways probably in previous areas?
Yeah, it's kind of hard to say. I would say a good chunk of the watershed in the near stream areas certainly became hydrologically active, but you're right, probably the outer fringes of the neighborhood, the watershed probably didn't have active runoff that made it to the stream proper. But yeah, this was the best we could get. We got ready for several events, and of course, when you prepare for an event, it never rains.
Yeah.
And then when it does rain, a lot of times it happens on the weekend, and so we couldn't get out there and get our samples. So we took what we could get here.
Yeah, that's what I thought.
Yeah. So Moving on to lead, we did some low-level lead analysis, and we did find lead in all surface water samples. It's pretty much ubiquitous. And these are the samples that we collected by hand. Somewhat similar to titanium, the highest concentrations of lead that we measured were actually at Schneider Road here, so coming in upstream of the airport. And all of the concentrations of this low-level lead measured in surface water were below our screening level analysis limit of detection, which is 5 micrograms per liter. So these would have been all less than detect if we hadn't requested the low-level trace analysis. And finally, we did isotopic analysis of that lead as well. And we took all of the hand collected water samples and had them run at the lab for non-radioactive isotopes of lead. The lighter orange colored circles are from the surface water runoff event. So here and here. And then the red circles here are from the base flow event. So the closer each one of these circles lies to one of the benchmark standards here, the lead ore down here and the coal fly ash up here, the more of that particular source is likely in that sample. So you can see we're between the fly ash and the lead ore. And so all of the samples had that signature, and none of them had a strong signature of the triangle up here, which is the avgas. All right, back to Laura to talk about soils and shallow groundwater.
Yes, so in addition to the drinking water wells and the surface water, we also collected soil samples from the locations shown here on the map. And at each location, we collected soil at 2 depth horizons, about 1 foot deep and about 2 feet deep. And then we also collected shallow groundwater, or what on the plots is labeled as pore water, which ranged from between 2 and 11 feet deep at all of the same locations except Z1 sort of to the west of the runway there. Yeah, we pounded into like 15 feet deep and we couldn't get any water, even though we were standing next to a creek. It was lovely. So there's no samples for that site. All right. So we've got some lovely field photos, action shots of me and Jason Smith out in the field, pounding those posts in. All right. So so this is looking at that shallow groundwater. We did find some metals associated with fireworks in that shallow groundwater. Here I'm showing zinc and chromium plots. And these showed up above the drinking water enforcement standard. But once again, these are very shallow groundwater, you know, about 10 feet or less below the ground. So these don't need to be held to drinking water enforcements. And the highest levels were found at sites A3 and Z3. So you'll keep those in mind for the next few plots, A3, Z3, yeah.
So A3 was here, right? And Z3 is here?
Correct, yeah.
Yep.
So we'll show that again.
Mm-hmm.
And looking at some other fireworks related metals, we see that again, A3 and Z3 for here, lithium and iron also have the highest concentrations. In the case of lithium, all the other sites were below the limit of detection, which in this case is somewhat high, of 9 micrograms per liter. And iron was, that M on the plot there means that the iron was detectable, but below the limit of quantification for this method of measurement of analysis. Yeah, so that A3, Z3, like Todd pointed out, those two sites are close together, sort of at the eastern edge of airport property, east and southeast of the Rock the Ramp 2021 fireworks launch site. You click one more time, Todd. Yeah, that's roughly where the fireworks were set off. So there seems to be a bit of a connection between that launch site and those areas to the east and southeast, having higher concentrations of some contaminants. In summary, I'm not going to show any plots of the soils. They were all over the place and not very interesting. But we did not detect any gasoline range organics or BTEX in either the soil or the shallow groundwater. Many of the metals that we ran these in our panels were detected, but are naturally occurring in the environment. So we wouldn't be surprised to find them at detectable concentration in soils anyways. And there's no EPA or state enforceable limits for contaminants in soils or shallow groundwater like this, like there are in drinking water. All right, lead. So those same two sites, A3 and Z3, measured lead concentrations above the drinking water standard in the shallow groundwater. But when we take a closer look at the isotope analysis, we don't have isotope analysis for Z3, but we do for A3. And we see that A3 on this plot is that right green dot that Todd is pointing out. And it plots sort of right between Wisconsin or Madison rainwater and the Galena lead ore. And then those blue dots are samples taken at an area to the west of the airport property. And these have isotopic signatures very close to local rainwater. All right, so sort of a high level summary of what we talked about, sort of focusing on groundwater, although the surface water also has interesting things to say, but we're focusing on the groundwater here. So for the homeowner wells, some of the outdoor taps seem to have treated water in some way. We had a few MCL exceedances for nitrate, arsenic, and perchlorate. We did see that those very low concentrations of lead well below the MCL and the isotopic signatures of those lead concentration of those lead that we detected were somewhere between rainwater and avgas. And for the shallow groundwater, we found chromium, zinc, iron, lithium, and perchlorate were detected at the southeast side of the airport, some of which were above an MCL if you were to apply that to groundwater. And the highest concentrations of lead we detected in shallow groundwater were in those same sites southeast to the fireworks launch site. And the sources of this lead were, again, in this case, likely between some mix of rainwater and local lead ore materials. And then I don't know how much time we have for questions. We did answer some along the way, so that helps.
I just have one quick question. Actually, it's a correction on the previous slide. So it says low concentrations of lead well below MCL. There isn't actually an MCL for lead. It's an action level.
Oh, thank you.
So that you might want to change that.
For sure.
But great presentation, both of you. It's the second time I've seen it, so it's great.
Yeah, this is Warren. Good presentation, Todd and Laura. What was the feedback you got from the town of Middleton?
Yeah, they were appreciative of the study. Not really sure where else to go. Let's just say this: when we presented the results, there weren't that many questions. We sent all of the results with a pretty descriptive letter on what their data meant to the homeowners, and we were expecting a fair amount of emails or phone calls from that. We didn't get any. We did try to run the blocker scheme there, though, is that we had a resource at the Department of Natural Resources who specialized in drinking water and contaminants of that nature. And so we gave them that information, basically said, hey, if you have any questions, this person is better to talk to than we are when it comes to that. So like treating your water, you know, so yeah. I think it's somewhat similar to, you know, the to me, the news, you know, especially when it comes to lead, is that, you know, it's there. and we can see it, and the avgas signature is likely there, but it's at low level. And so then it gets into a little bit of debate on whether it's okay to be there or not okay to be there. And then a discussion ensues about is EPA right? Is that number going to keep people safe? Those sorts of things.
Right, is
So,
that 15 micrograms per liter, is that,
Yeah.
should that be the action limit, or should we be taking action at some much lower level than that?
and luckily we get to stay out of that discussion. We're just the messengers.
Was there any thought on or way of determining if any of the lead was from the gunman's club that used to be out there?
Yeah, that's a really good question. And we had definitely thought about that. And the fact that those lead concentrations were highest right over in that area, and a lot of them had the signature of the lead ore material, I think it's a possibility, but I don't think we can really, we would have to take samples of that lead. And my guess is there's just, lead is sourced from all over the place. So
Right.
You could probably never have that smoking gun, but it is definitely a possibility.
But there seems to be some higher concentrations coming from Schneider Road and upstream sources of some metals. So,
But those concentrations were quite low compared to what we saw in shallow groundwater.
for lead, you're talking about.
Yes, yeah.
Yeah.
Okay, if not, any more questions? If not, thanks a lot, guys. Appreciate it.
I have one, Warren.
Okay.
Todd and Laura, do you have any direction from the town as to whether or not you're going to move forward with the rest of this scope?
Nope. It looks like we just talked about this the other day. It looks like we're just going to, compile what we have and put it in a report and get it out there. So it's just kind of a one-time synoptic view of what's happening out there.
It would be kind of nice to get a higher runoff event, but that's kind of pricey.
Yeah, and what we really wanted to do was, you're right. You're right. We could be washing off lead sourced from further up in the watershed, but I actually kind of appreciate the fact that we had a relatively low event, because otherwise we would probably be seeing much lower concentrations due to dilution. And I thought we probably saw some of the maximum concentrations that we might see in overland runoff because the event was relatively small. And we wanted to see that lead on and around the airport proper. And so by that token, we didn't have this potential masking of this giant event coming downstream. So I think it worked out okay.
Okay, thanks again. Don't
You
go away,
bet.
Todd.
If only I could, if I could go.
Yeah, you guys get to keep
Laura-
time.
Laura, you can check out unless
Yep.
you want to learn about the Hara River watershed, but
Thank you.
I'm sure you have things to do.
Yeah, I'm gonna sign off. Thanks, everyone.
All right. Thank you, Laura. Bye.
Thank you, Laura.
Thank you.
Bye.
So Warren, next item on the agenda is another report from Mr. Stuntebeck.
Okay.
And Todd, why don't you just take it away?
All right. I'm having a hard time seeing which screen you guys are seeing. So can you see my slide there? You hear River
You see
Watershed?
your cover slide, yeah.
Okay, good enough. All right. So Eric, you were at this meeting, I take it, in December?
It was.
Okay. So every year about December, I give a presentation to the Hara Winds group at MMSD. That includes obviously the group there at MMSD, but all the other constituents like City of Middleton, all the other players that are in the Hara Winds adaptive management project. And I give them an update on what we measured from a water quality perspective in the Hara watershed from the major tributaries. So Eric was at this meeting. He apparently loved what he saw, and so he asked me to come and give this presentation to you guys tonight. So I'll give the same presentation here. I'm going to zip through a few things faster than I typically do, just because you have such a knowledgeable crew here, I think. The Dane County project has been around in the USGS for quite a few years. I took it over maybe 15 years ago or so. from Herb Garn, who had it from Kevin Richards. So it's kind of been passed along the line. And as of right now, we have all of these monitoring stations out there that you see in these different colors. There's certainly other USGS stations out there within the Yahara River watershed. I'm just going to focus on kind of the big picture type sites. And we have different colors representing different functions. The purples out here are, we have stream flow monitoring and high intensity water quality sampling going on. The red ones, we have the same thing going on, but we have to use a little bit different equipment because we have backwater from Lake Mendota. We have an urban monitoring site here at Spring Harbor. We've got a site here down at Swan Creek, down here at the Yahara River down by Fulton, near the mouth with the Rock River. And then these pecker colors you see in here are lake level and stream flow only sites that the county uses to set their dams to make sure that the lake levels are where they need to be. And we also have 19 long-term basal monitoring locations that we sample several times per year on a rotation. I'm not going to go into that tonight, but just know that those data are available going back for quite a few years. So there's basically two things that we're looking for at our sites. One is stream flow, and the other thing is periodic water sample concentrations. And when we get enough of each of those, we can combine those two to generate a daily load. And that's kind of our goal here, is to have daily loads, pounds of phosphorus or tons of sediment. Some of the sites we also have nitrogen species. Some of the sites we have chloride. For example, at Spring Harbor, we're looking at chloride very closely there because of well 14. Which just got shut down the other week, I heard. USGS uses our matching dollars to collaborate with people to allow this work to happen. City of Middleton has been a huge partner over the years doing various amounts of work. And in fact, I'll go back here. I'm a little remiss in not pointing out that these three sites right here are funded wholly by the City of Middleton and with excuse me, I'm pointing at my screen, not this screen, funded with USGS and dollars from City of Middleton. Most of those sites were up in the Mendota watershed. Clearly, this is the largest area to monitor. We also have 4 primary tributaries coming in there: Pheasant Branch, Dorn, 6 Mile, and the Yahara River. It's important to measure up there because we have this huge agricultural watershed, and it's definitely impacting our water quality. And it's important to understand when it's coming in, where it's coming in, and what the long-term trend is, so that we can make good decisions with our landscapes and our water. It's also really important to understand what's happening in Mendota because it's the most upstream lake, and the pie charts here show the little blue chunks there. That's the amount of phosphorus that's coming in from the upstream lake. So Lake Monona, for example, has roughly 60% of its phosphorus coming from Mendota, and you can see Wavisa and Kaganza are affected as well sequentially. I think we all recognize we have a problem out there. We have challenges with blue-green algae, E. coli, macrophytes, all sorts of things that are impairing our ability to use our water resources in the way we really want to. And we all recognize that the big gorilla in the room is phosphorus. So that's what I'm going to focus on here today, is our phosphorus numbers. Lake Mendota, I'm going to focus here on Lake Mendota for a little bit. Each blue square on this plot here represents the median concentration in the center of Lake Mendota between July and August, going all the way back to 1980. Where we really want those dots to lie is somewhere below this line of mesotrophy, below 0.024 milligrams per liter, because when we're down there, we have better water quality. There's less opportunities for vegetation growth and algal growth, things to get out of control. And you can see it's changed quite a bit over the years. 1993, if you were around back then, that's when the Mississippi River was blowing its levees out. If you live in the lakes, 2008 and 2009, the lake levels are super, super high because we had lots of runoff during those years. And in 2019, I'll get to this in a little bit here, we had record high runoff and record high phosphorus loading into the lake. So that's kind of our long-term story right there. And I'll take that same plot and superimpose the loads from the Yahara River monitoring site at the Lake Windsor Golf Club, only to demonstrate one thing, that the linkages between what is coming off of our landscape and the concentrations that we measure in the lake are quite strong. So we had a high loading year at Yahara River here at Windsor, we had that corresponding high concentration in Lake Mendota. Same thing happened here in 2019, although the response to the lake wasn't nearly as strong. And conversely, if you look at the dry years, 2001 and 2002, we see low loading here and we see low concentrations in the lake. 2012 was also a dry year as well. And in fact, 2021 and 2022, which I'll talk about a little bit here, we've had a very low loading into the lakes compared to our historical numbers. I'll skip over that. I did some math a couple years ago just to estimate the overall contributions to Lake Mendota. So we could look at a pie chart. This doesn't include any sort of, groundwater upwelling, phosphorus upwelling into the lake. This is just kind of the surface inputs to the lake. And you can see that, Yahara and 6 Mile comprise a really big chunk of that phosphorus coming in. Pheasant and Dorn are quite a bit behind each of those two. But of course, there's other sources as well. The green part of the pie chart here is estimated coming in from the Madison urban area, and that's from the Madison's modeling. And then we of course have some direct deposition through rainfall and dry fall. And then there's a little area, our gauge in Middleton there that isn't at the mouth. So there's some contributing areas that we're not actually measuring there and along the north side of Lake Mendota. And so I put a little estimated chunk in there as well. So overall, we're looking at around 75,000 pounds a year between 1990 and 2022. Most of that's coming in from the Yahara and the 6 Mile Creek watershed. And as far as the timing, this is also important to understand, is that most of our phosphorus gets into the lakes during the winter, and mostly in February and March during snow melt. Long-term averages around 50%. If you go back even further, these are only data from 2013 through 2022. But that early part of the year, and April through June as well, is another big period. Think about that when we're out in the landscape, we're doing things out there. Our crop canopies haven't been developed yet, so they're susceptible to runoff and phosphorus losses as well. Stream flow. Real quickly, we don't have the technology to directly measure stream flow, so what we do is we measure water level. So here's an example of the water levels at Dorn Creek at Highway Q for the last year. Those data are collected every 15 minutes during low flow periods and every 5 minutes during storms. And then we go out there periodically with fancy equipment like this, and we measure what the flow is in the channel. It gives us a really cool picture that looks like this. This shows the velocities in the stream. And we can see at this particular, for this measurement, the green and the yellow and a little bit of the orange there, we're getting up to 1.5 feet per second or so. And over here on the right-hand side, we have a little bit of eddy going on. And at the end of that measurement, after we do a little bit of trimming of the edges and modification of it, we get a discharge for that particular measurement. And that measurement turns into a red dot on this theoretical rating here. So we create a rating curve between discharge and stage. And that's how we can convert our stage data to discharge data for the year. So the big challenge for us is that this is reality up here. Yeah. So everybody likes to see this lovely theoretical, especially you, Ken. The theoretical rating curve here is we call this our base rating here in red, and that represents conditions like today. Like if you were to go out there today, we don't have any ice in the channels right now. We don't have any weeds, significant amounts of weeds growing. So we have our base rating right here. But when we get out there into the summertime, the streams look a little bit more like this. And so we spend a lot of time making measurements and shifting from this base rating to this one in blue here, for example. And so we have to do that periodically and constantly throughout the year, especially at these low gradient stream sites that are tributary to Lake Mendota, to make sure that we get good, accurate discharge. And then there's 3 sites here on the upper end of Lake Mendota that are all affected by backwater from Lake Mendota. This is the Yahara River coming in at Highway 113, 6 Mile Creek at Highway M, and then Dorn Creek at Highway M. And then we also have a site where just downstream of Tiny Park Locks here, we have a site on East Main Street that's subject to backwater from Lake Monona. And here's an example of velocity at one of our sites, and the zero velocity is right about here. And you can see we have some negatives going on there, especially this particular event right here where we had greater than 1 foot per second moving upstream or negative flow. And that's an event in which we had winds setting up from the south or west or the southwest side of the lake, pushing all that water up to the north and east, and water squeezing back up that channel up into Cherokee Marsh there. And that's what creates that negative flow. Well, our standard stream gauging doesn't work there, so we have to use hydroacoustics again. And we have an ADVM sitting out there that insonifies a portion of the channel. And we still have to go out there and make measurements, but we're relating the average velocity of our physical measurements to the velocity that we're measuring at our index site. We call this our index velocity method. Okay, water quality. You already saw it in my Maury Airport discussion. We have auto samplers, refrigerated auto samplers out there that do a lot of the work for us. There's a hydrograph on the upper right here that shows some samples from an event back in 2012, and each of the red squares on there represents when a sample was collected. So we don't have an unlimited budget, so we can't run all of the sample analysis for all the samples that we actually pump. We're shooting for around 100 samples per year on average. So what we do is we empty out those samplers, we bring them back to the laboratory, we take photos of them, and we evaluate which ones we think are the best representation of the variability in water quality through an event. And then we process those and we submit those for analysis. And on a big event, we might submit as many as 8 to 12 samples. For a small event, maybe as few as 3 to 5. And again, we're primarily looking at total phosphorus and dissolved phosphorus and sediment, either total suspended solids or suspended sediment, depending upon what the cooperator needs. But we've done a lot of different samples concurrently, and those are pretty much interchangeable here with streams in the Madison area. And the exciting part for me is at the end of the year, when we finally get our discharge done and we finally get all of our concentration data back from the labs, we combine those two pieces together in this fancy program called G-Class. And we hit a button and it gives us our daily loads. That's not to say we don't have a lot of work to do when we pull these together. We do have to make estimated concentrations at the beginning of storms, at the end of storms, sometimes if we miss an event or two. So there's a little bit of looking at and tweaking that we need to do before we feel comfortable hitting that compute button. All right, 2022. So I'm with the government. My life revolves around the water year, which starts on October 1st and ends on September 30. And I would be remiss, we just can't talk about what's happening as far as phosphorus in a year without really talking about the weather, because the weather is really, really, really what drives our phosphorus coming off of our landscapes. So here's our weather in 2022. The blue line on here is the cumulative precipitation that we get on average between October 1st and September 30th. It's about 37 inches or so. And this is using the 1991 to 2020 average. So 37 inches a year. When I started work, I think it, over 30 years ago, I think it was about 31 inches, 32 inches or so. So hint, hint, we're getting more rainfall. Wanted to focus in, I'm going to step back a year here to 2021 and just show you that starting here in about March of 2021, our actual precipitation, which is shown here in green, is lagging quite a bit below that blue line. And so if we have 21 on the left and 22 on the right, we have this long period in here in which we had pretty droughty conditions. And just keep that in mind as we look at the data for these last few years. Here's our stream flow record. This is the combined flow from Doran 6 Mile Pheasant and the Hara River. And remember at the beginning of 22 how dry it was? Well, there's not much happening out there. It's basically just groundwater discharging into the stream. And it wasn't until February or so we saw a little bit of runoff from snowmelt. Not a lot, but a little bit. And then we had a few runoff events throughout the rest of the year. So overall, it was a pretty quiet runoff here in 22. Well, how does that compare? What does that mean? Let's see some other years here. Sure. Let's go back to 2019, 2020, and 21. So here's our 2022 over here. We had 34 inches of precip. We were a little bit less than normal. Go all the way over here to 2019, and we had record high annual stream flow. We had 45 inches of precipitation. The snowmelt runoff was absolutely incredible. So huge contrast in between 2019 and what we saw in 2021 and 2022. 2020 was a pretty normal year from a runoff perspective. It was still a little bit high. We had quite a bit of precipitation, but it's interesting to note that even though we had more precipitation here in 2022, we actually had 20% less flow than 2021. And then we only had 25 inches of precip in 21. Well, how can that be? Well, the answer is base flow. Most of the flow that we measure on an annual basis in our streams is base flow. So the conditions that you see in a stream when you walk out your door today, it's base flow. It's groundwater discharge, discharging into that stream and then flowing downstream. And during that drought period there, you can see here that this line here represents the approximate base flow. You see it's decreased significantly between 21 and 22. So that is why, even though we had more precip in 22, we had less overall flow because that base flow had been depleted quite a bit. Phosphorus loads, we finally get to the phosphorus loads. So same blue line that I showed you before, but now we have this green plot on there, and this is the cumulative phosphorus load into Lake Mendota from all 4 of the tributaries summed together. So overall, we had about 30,000 pounds of phosphorus coming into Lake Mendota in 2022. And when you see kind of a low slope to a line right here, that means there's not a lot of phosphorus coming in. But when you see a steep slope here, those are periods in which phosphorus is being, is coming off of our landscape and is being moved downstream by our tributaries. 2021, remember I said it was really dry in the back half of 2021. Here it is. We just didn't really see hardly any events in there. We had one event at the beginning of the year, but overall it was a very low phosphorus loading year, around 25,000, 27,000 pounds or so. So I'll put that in perspective again with good old 2019. We had about 150,000 pounds come off in 2019. Over 70,000 pounds of that ran off in just 10 days during snowmelt of 2019. So we had our long-term annual average is around 65,000 pounds for the 4 tributaries. So we had an annual load occur in just 10 days. It was quite tremendous. 2020 was really pretty close to normal. It was around 65, 70,000 pounds. And then here you see 21 and 22, a really low loading year. So if you live on the lakes, and if what I'm saying is true, or what the limnologists are telling me is true, you should have experienced fairly decent water quality in the lakes these last 2 years, actually. So here's our long-term trend. The red line on here isn't actually a trend, it's just our average line. If you would put a trend through that, if you've done any sort of stats, you can see that there's really not a meaningful trend there. We're not moving the needle significantly. There's a lot of low loading years here in the 20 to 30,000 range, but they're being offset by these big, huge years here where we have, 2 times or 3 times our annual average coming off in a year. So there's not a lot of trend there. Dick Lathrop and others put their brains together and determined that a good goal for Lake Mendota loading would be somewhere around 30,000, 32,000 pounds or so. So we really, if we want to get to where we have consistently good water quality in the lakes, or at least improved water quality in the lakes, we really need to move the dial a long ways in order for that to be realized. So this plot here doesn't do a good job of showing trends. We have a program called weighted WRTDS, weighted regressions on time, discharge, and season. I won't get into how it works, but I started using that in 2015, and I realized that there was a story there. I haven't really had the resources to really explore it, but Matt Dybel at Dane County did have the resources to do that this year as part of the the Yahara Clean 3.0 effort, which I know the city of Middleton was a contributing member. And this is pulled directly from the Renew the Blue report that came out in May, I believe. And this shows the Yahara River at Windsor on the left and Pheasant Branch on the right. And this orangish colored line here represents what the load would be at the Yahara River at Windsor if the flows had remained stable for the entirety of that period. So from 1990 through 2022. So what that's saying is if the flow doesn't change much, our loads would actually have decreased over that time period. Guess what? Our flows are changing. Our flows are going up. And so this green blue line here represents more of the reality of what we're actually seeing out there. We're seeing actually an increase in phosphorus loads at the Yahara River. Pheasant Branch is a little bit different story. This is in your guys' backyard here. We're seeing our long-term flow normalized loads coming down over time, flattening out here perhaps over the last 15 years or so. And then this is our kind of our short term as well, and we're flattening out as well here. And that this decrease here almost certainly has to do with all the urbanization that occurred in the South Fork from the 80s to the 90s to the 2000s here.
What is the timeline on here, Todd? Or is there
Yeah.
a timeline on this?
Yeah, it's on the bottom here. I'm sorry. It's 1990
Oh,
through
there it is.
2020.
Sorry.
Yeah, so it's about 30 years or so.
All right, thank you.
And WRTDS isn't super appropriate to use on relatively short time frames. Ideally, you're using 20, 30 years of data. So it's good to use on the long-term data sets that we have for the Yahara and Pheasant Branch Creek. But we just started in late 2012 monitoring 6 Mile Creek and Dorn Creek as part of the Yahara Winds project. So we don't have that much data. But what the heck, let's run it through the analysis anyway. So again, this is from the Renew the Blue report. And what it's suggesting is that at Dorn Creek, we're not seeing a real big change here, but there definitely seems to be some sort of significant decreasing trend on 6 Mile Creek. So mixed bag here, some good news, some bad news. But the reality is we really are fighting against Mother Nature here. Over the past 150 years, excluding something that happened in the mid 1880s. I don't know if there were pranksters around back then, but getting over 50 inches of rain here, yeah, I don't know, maybe some of our ancestors thought it would be pretty funny to, who knows, but 9 out of the 10 highest annual precip totals have occurred in the last 20 years. We're still getting these relatively dry years, but the dryness keeps going up and up and up, it seems. And stream flow trends are going up as well. So here's a number of sites down here in southern Wisconsin. The longest term record we have on this plot here is East Branch of the Pecatonica River. It's showing an increasing trend going all the way back to 1940. Black Earth Creek going back to 1950s is increasing. Here's our Yahara River site. Spring Harbor is down here. So we're really up against it. We're really fighting. And although there's been a ton of progress made on the landscape, both in the agricultural and the urban areas, it just hasn't been enough to be fully realized in the lakes. And so I think Lathrop and others have coined the terms such as staying on the treadmill or holding serve or treading water. And I always put this paper up here, the Shifting Drivers paper by Gillen, Booth, and Rissman. And the notion here is that, yeah, we're doing stuff. This is great. But we can't have our blinders on like this because the world is changing around us. We're focused on conservation efforts, but everything is changing. Our precipitation and runoff is changing. The way we develop and urbanize, our watersheds are changing. Agriculture is changing. Believe it or not, ag doesn't stay the same. They do different things year in and year out, and they try different things. So there's just so much variability here. But in order to really cut through all that variability and get the phosphorus levels to where we need to go, I think we really need to think outside the box and take bigger swings. If you've been part of the Renew the Blue effort, you're very aware of all the different things that are happening out there. So I'm just going to show a few slides here of cover crops, for example. This is the Suck the Muck project, taking that phosphorus laden sediment out of our low-lying areas. urban areas such as the street sweeping. We know that phosphorus concentrations are high in the fall due to this, phosphorus tea that develops on our streets. Composting of manure is being tried by Yahara Pride Farms. We have manure injection so we can get that manure subsoiled so it's not on the surface ready to run off. We have different ordinances out there now affecting what we can and cannot do on our winter frozen ground landscapes with manure. We have manure digesters out there in Middleton and Wanakee. There's discussion now of a larger community digester as well. And again, if you haven't read it, all sorts of really good information in this Renew the Blue publication here. And that's all I'm going to go into tonight. I know you guys have more meetings, more things to discuss tonight, and that's what I have.
Great job.
Yeah, very good, Todd. One question, do you have any, to suck the muck, do you have any, the two sites on Dorn Creek, have you shown a decrease in phosphorus or sediments because of that?
Well, I just happen to have this slide right here. It's almost like you and I talked about this, Warren, but I swear we didn't here. So this is a little bit of a spaghetti plot here, but these, going back to 2013, as part of the Yahara Winds project, as part of the WISCOM guidelines, we go out there once per month during May and October, the growing season, May through October, and collect a sample, a phosphorus sample on or near the 15th of the month. And we take the median of all of those concentrations for the year and we plot it up here and we compare it to our phosphorus goal, which is our 0.075 milligrams per liter for most smaller streams, 0.1 milligram per liter for the larger streams. And you can see that all of our sites here are greater than our goal. However, what I want to point out from this plot here is that I have done, this is totally preliminary, Warren. There hasn't been anything published or anything like that. But between Dorn Creek at Q and Dorn Creek at M, that's where the first Suck the Muck project took place. And they removed all sorts of sediment between there. And this red line right here is Dorn Creek at Highway M. And the dredging occurred in 2018. And after 2018, we saw a precipitous drop in the concentrations, the base flow concentrations out there that exceeded those drops that we had seen in other sites. So I think it is very possible that we are actually seeing a reduction there. However, we're seeing an uptick here during the last 2 years. And my hypothesis there is that we've had such low flow during base flow periods when we collected those samples that we may be seeing some higher concentrations due to lower flow. So we have more interaction with lower flowing water over those bed sediments, and we have desorption of the phosphorus from those particles into this to flow and so forth. So it's not definitive, but I think that we can see a little bit of a reduction there. The bad news, so that's the good news. The bad news is the base flow loads are not significant. In general, we see 80 to 90 or more percent of our percent of phosphorus is coming in during storm flow. Sure. So unless there's a significant trapping effect of that dredging, just getting that phosphorus out is not necessarily going to lead us down a path to greatly reduce phosphorus loads. It's strictly kind of a base flow effect, unless again there's a significant trapping going on. And I can tell you, based on photos that we take every day, we actually have cameras out there that are viewable by the public. Post dredging, the area just upstream of the Dornet M culvert was pristine. Now it looks exactly like it did 3 years ago. So all of the sediment has come down, the weeds are back and so forth. So again, Mother Nature seems to be winning here. So.
Okay, thanks. Any other questions?
I had one quick question. Todd, I enjoyed your presentation, and you clearly demonstrated the weather whiplash that we're going through is having a large effect on the phosphorus loading to Mendota. Does USGS has having discussions right now or plans about how you all might modify or adapt sampling now and in the future, given this, how important these high flow events are? They're becoming more sporadic, but more intense.
We've got everything out there to do it. We have auto samplers. Dick Lathrop in the old days, back in the 70s and 80s, when he was a master's student, he would run around and cut his foot on glass in the streams and all that kind of stuff. But
Yeah.
I'm sure you've heard that story many times before.
Yeah.
But yeah, these auto samplers are a real lifesaver. And and we have the other really cool thing here is when one of my first projects when I started at the USGS was at a site that was 3 hours away. And, we had real-time communications with the sites, but we didn't have any kind of graphical representation that was really good. But now at my fingertips on my cell phone, any hour of the day, I can pull up what the site is looking like, what the conditions are. And so I can adjust thresholds on the fly. I can adapt to pretty much anything that is thrown out at us out there. So I'm pretty confident we have the technology to really pepper these hydrographs with samples.
Yeah, very cool. Thank you.
I gotta ask Todd, Jim here, is there a reason why you've chosen to go with discrete sampling during the events or as opposed to flow weighted composite sampling during the event?
Yeah, yes, we would save a lot of money, but the reality is we don't know. I mean, there's so much shifting going on in these streams. We are not confident in the discharge at any given point in time, right? If we went out there today and made a measurement and we put the shift on and then we had an event tomorrow, I might feel a little bit better about it. But I mean, there are sites where there's for let's say a flow of 10 cubic feet per second, there can be a 2 to 3 foot difference in the water level for that same flow in that same stream. So that's the reason why we don't do that. I do have edge of field sites out there in agricultural areas for the Discovery Farms program, and we have H flumes out there. There you have a pretty solid control structure, and we do flow composite sampling at those locations. It's a lot easier. You don't have to deal with millions and millions of samples every time.
Yeah. Okay.
Lisa?
Thanks. I really enjoyed the presentation, Todd. I'm looking at the slide, the 15th of the month growing season total phosphorus concentrations preliminary, and I'm just seeing how high everything is above the goal. And so my question is, are you aware of any places in Dane County where the goal is being met?
Yeah, I am not aware of any off the top of my head.
Okay.
Yeah.
Black Earth Creek might be the best chance.
That would be my first guess.
Yeah, that's probably all right.
Yeah. And I don't want to get into this too much, but this is always a big frustration of mine is that basically for the Hara Winds permit, this is part of what they have to do, collect a sample on the 15th of the month. And in fact, anybody in the state who is going through this adaptive management process has to go through this. Well, we're putting conservation out there in the landscape. Improvements to conservation are going to show up in the storm runoff, not in the base flow. Now, eventually we might reach an equilibrium, decades and decades and decades from now, but this is not the best metric. But I understand DNR's situation here when EPA comes in and says, thou shalt do this, and there needs to be some monitoring and some rinky-dink operation in a little town of, 3,000 people. They're not going to be able to do this high-end, monitoring like we do. And we are fortunate not only to have, the city of Middleton involved, but to have MMSD do sampling well above and beyond what the requirements of their permit. And it's really, really helping us to fill in the full picture of the lakes here. We didn't have monitoring on Dorn Creek and 6 Mile Creek until 2012. We tried it a little bit back in the days with Dave Grachik and the kind of the infancy of hydroacoustics, and it was very difficult. I had mentioned we have these low gradient backwater, weedy streams. This is like the worst place you could ever want to go to measure flow. It's very challenging.
One more question, Todd, is on the North Fork of Pheasant Branch, digesters are going in the watershed.
Yep.
So how much of the watershed will be affected by digesters, or how many farms?
It's my understanding that almost all of the farms out there, except one, are part of that digester. And that's pretty exciting too, because they have now, they have tertiary treatment now. So they have potable water coming out They're removing a significant amount of phosphorus, from the watershed. And I really, once we get a few more years of data here, I really want to do an analysis, especially looking at that snowmelt time period, because just based on my eyes, what I observe with the water samples, we're not seeing nearly the manure and the runoff that we used to back in the day prior to the digester. So I do think that it's had a pretty significant effect. If for no other time period, but that winter snow melt period, or late
So
winter, early spring.
yes, that's the importance of us keeping the North Fork gauge running for stream flow and phosphorus and sediment.
Oh, that
Because
was a
we
nice
don't-
lead into the next thing in the agenda, I guess. Huh?
That's right.
You sneaky devil.
Okay. So we do have before digesters and afters, so that should
Yes.
be good information.
Yep, it definitely should.
Yeah. Okay. Thanks again, Todd.
You bet. I got to go curling now.
Okay.
Yeah.
Hope you make it in time.
Well, it's 3 minutes down the road, and I don't start until about 8:45. So,
Okay. Have fun.
all right. Thanks, everyone. Have a good night. Take care.
Thanks, Todd.
So the next topic is our annual monitoring agreement with USGS.
That's correct. And yeah, that's perfect lead in. We share costs for 3 of these gauges, and this agreement is for the 2 ones on the North Fork and ones on the South Fork. Warren, how many years have we been funding this? 15?
Yeah, and
More.
Corps of Engineers, it's 3 years back in 1990. So we got about 15 years of data. Yeah.
Okay. So the cost for this year are $35,000 to the city of Middleton, and 10,000 is covered by USGS. We've been paying for these out of TIF funds, TIF 3 funds. And staff recommends we continue to fund this.
So move.
Second.
Question?
Owen,
This is
you have
Julie.
a question? Do you have a
Yeah,
question,
this-
Julie?
Yeah, what was it last year? The amount?
Same cost.
Okay.
That's surprising. I guess they didn't get a. I guess they didn't get a raise.
Warren's not getting this cut this year, huh? Is that what it is?
Okay, we have a motion and a second. So all in favor?
Hi.
Aye.
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 I,
Opposed? Motion's carried. Okay, the next item then is flood mapping discussion.
Yes, Steve Gaffield has been patiently awaiting. When we met in November, there were a couple of items kind of hanging out there that we asked EOR to go back and flesh out for us. And so Steve's really got 2 items. One is kind of polishing off that scenario modeling, and the second is an amendment to carry forward with the flood mapping. Steve, I think you can take it away if you're all right with me flipping pages for you.
Yeah, that's perfect. Thanks, Eric, and good evening, everybody. Let's see, to refresh your memory, we had been looking at flood storage areas, South Pond and Esser Pond back in November. We talked about regulatory implications of that. The reality is both of these ponds capture and detain some of the bigger flood flows that come through the South Fork and provide a benefit downstream. The floodplain mapping that EOR completed back in 2020 factors in that flood storage, and DNR says that's great, no problem, it's reflecting reality. The but is you need to protect those flood storage areas. And at Eric's request, what we presented in November was looking at some options about, could you shrink the areas that are designated as the flood storage zoning overlay, change the modeling accordingly. So, and it's a refresher, you can do this. You can model the full flood storage and the downstream benefit, but you can also model part of it, which has less benefit downstream. In other words, you'd map more extensive floodplain, higher flood elevations. But that's allowable as long as there's a match, as long as the models in the maps match up. So, Eric was interested in looking at, can those flood storage areas be reduced to perhaps only be on public property, relieving some of the burden that zoning overlay for flood storage would create on private parcels. The one scenario that we did not analyze and present to you in November was looking at the possibility of only reducing the flood storage at Esser Pond and leaving the full flood storage at South Pond. Eric, let me just pause a minute and see if there's anything you want to add in terms of perspective here.
Nope, not at all.
Okay.
Yeah, on this map, the difference was, we've always kind of kept this orange boundary of where we'd have a flood storage district. And then the extra question was, what happens if we remove these private lands outside of the orange area and the street right away that the city owns or the DOT owns in this purple area? So that's what Steve went back and modeled again, independent of South Pond alterations. So the new model scenario is full storage in South Pond, and Esser Pond shrinking the storage that was modeled just to that orange polygon around the pond that Eric described. Consistent with what we were reporting back in November, we're looking at the 100-year event, stages and discharges in selected locations. So if you look at South Pond, the first line in the table, the first column, the full flood storage area, is the original run from 2020, modeling the full flood storage in both of those ponds. The new scenarios, the next column over to the right, reduced flood storage at Esser, full storage at South Pond. So at South Pond, that makes this slight rise, 0.3 of a foot at South Pond. Sorry, 3/100ths of a foot. Again, at Esser Pond, where the change is in this scenario, it's more than 0.3 of a foot. So, much bigger rise. And again, makes sense. You're reducing the simulated storage at Esser Pond. The Esser Pond predicted stage, pops up more than over at South Pond. And again, these ponds are connected at something to the tune of the 40-year event, although it's probably a more frequent event now, the way flood frequencies change. But Eric, you can correct me if I'm wrong, but I think the design was that 40-year event would cause overflow from South Pond over to Esser. That was my understanding, but I mean, all that prior work also shows a floodplain that's almost not even comparable to what we're showing now.
Yeah.
Steve?
Yeah, Jim.
Quick question. So under this middle column with what we call full storage at South Pond, that means accounting for the storage on that private property to the west of South Pond, right?
Correct. Yep.
All right.
So it's
Thank you.
making any change. If there's actually flood storage there, it's in this model run.
All right.
Yep. So you can look, if you look at the railroad crossing just downstream of South Pond, this is essentially what's the discharge out of South Pond. Yep, right there, Eric. This scenario predicts a very small increase in the discharge there for the 100-year event, 2 cubic feet per second. And then the impact of that increase when you get downstream, the north side of Highway 14 along the South Fork. We predicted a 1/100th of a foot increase in the flood elevation there.
Would you suggest that those numbers, especially at the upstream of the railroad crossing and the north side of Highway 14, those changes are within the confidence level you have of the model itself?
Yes.
Yeah.
Yeah. So, you know, as you well know, state regulations require, you know, reporting and showing no impact to 1/100th of a foot, you know, in situations where there's a development and a project. But I think everyone understands the models just aren't that precise, and the data that goes into them. So that's, yeah, those are the results. Pretty simple because it's just that one additional scenario. But that's the update on the modeling.
Yeah, I'll step in. I think it's significant enough that we don't remove the flood storage district from these lands surrounding Esser. Kind of similar to the co-op site next to South Pond. You know, there is perhaps opportunity to dredge and gain compensatory storage, you know, to still accommodate some redevelopment of those properties that have ended up in the flood storage district, which we would essentially have to do, or those properties won't be able to redevelop.
So your recommendation is to keep that land in flood storage then?
Yeah,
And Eric,
yeah, go ahead.
are you mainly basing that because of the 0.34 feet change at Esser Pond itself?
Yeah, and it was kind of similar with South Pond when we were talking about it.
Yeah.
There are downstream impacts, but the local impacts are greater.
Yeah.
And just as a reminder, the implications, if you were to shrink the flood storage district, the mapped flood elevation for Esser Pond would be that 0.34 feet higher than it would be if you did have the flood storage overlay. So the trade-off, that area would have the flood storage zoning overlay, but the lower 100-year flood elevation.
Okay. So do we have a motion for?
I have a question first. So if we follow your recommendation, Eric, what are our obligations with regard to the private property owners whose property will be affected?
Obligations, I think notification, basically. It is what it is. We're not gaining advantage or taking advantage or anything. We just need to alert people that this is what our study has found, and if they're at risk, they should be aware of it.
So this is not going to, help me out here, become, if we designate that a district, that area, it means they cannot change the volume of storage on their property. They have to, if they're going to redesign their lot for some reason, build a building or whatever, they got to find that volume somewhere to store, right?
Correct.
At least the portion of the lot that's in the floodplain.
Yeah.
What is the 0.34 feet for Esser Pond mean in terms of the area of the pond? I mean, what impact would that have?
Ken, we didn't map that. It'd be a relatively simple exercise to do. I guess, you can think about typical slope of the bank of the pond, which you might have a good feeling for, but say 10-to-1 slope.
3.6 inches, right? So we're talking.
Yeah, you know, 3 feet, 3.5, 4 feet.
If you're, the areas that we're talking about though are, or the edges of this now are within developed areas.
Mhm.
You know, so if you were in a parking lot, that 2% slope, that'd be another 20 feet
Mhm.
worth of parking lot.
Yeah, okay.
You know, we're already into the intersection of Greenway Boulevard and
Deming,
John Q. Hammond's
Hammond.
exit ramps. Yeah, it's a pickle.
Is there any legal reason why we can't? Is there any reason or challenge between, what am I trying to say? Keeping the DOT land in the district? Can we do that? We have that authority?
I think that's coming up in the next agenda item. One of the things, you know, Steve wants to kind of map out the process before getting started, and there are issues with, I mean, this is one of them.
Mhm.
Can we map flood storage districts in town of Springfield land? Can we do it on DOT land? I'd say yes, we can. You know, I don't know what to do here, except maybe think about this as we could use Esser Pond to provide kind of a reservoir of compensatory storage. And if a project came up, maybe that's part of the development deal, is we could offer space for them to conduct excavation, or we could perhaps even offer to do that excavation project ourselves.
We're talking about wetlands there, aren't we? Eric, that's gonna be a challenge, isn't it?
Well, it would have to be a wetland scrape. I don't think it should be permittable in some
We're not
fashion.
filling,
Right, we're not filling.
right?
They would probably want to put conditions on it as far as vegetative management, maintenance and things like that.
Mhm. I think that's an option to offer if the time ever comes when a property owner has a project that would in fact remove some volume. That could be a negotiating tool.
Mhm.
Dredging Nestor Pond's really expensive, like $2 million.
Wouldn't have to be, not.
Well, what I was kind of suggesting is we could do it chunk by chunk. If one of those, if the Fairfield motel wanted to redevelop, it could be investigated as an option, you know. Otherwise,
Yeah,
if that parcel of land became undevelopable, maybe we would rather, or maybe we trade that storage with 2 other parcels that want to redevelop,
yeah.
or advance with a better dredging project that maybe has a flood reduction impact.
Yeah.
Just a reminder on dredging, you wouldn't get credit for removing soil sediment below the groundwater level, below the normal pond level,
Right.
you know, because it's already full of water.
Yep.
And there could be, you know, some trickiness in defining, well, what exact elevation is that? But the prospect you've got for Eric's idea is, you know, mostly to the south of the pond, I think, but
Yeah,
around the fringe.
yeah.
So what are we looking for, Eric? A motion for,
I think you've already,
If a motion to accept my recommendation or reject it.
yeah, okay.
And the recommendation, can you state what the recommendation is? So are we moving to accept the recommendation to maintain the full floodplain storage district for South Pond and Esser Pond?
You had already done that for South Pond in November. This would just be for Esser Pond.
Okay.
Okay,
So that's the blue shaded area. It means that the city needs to realign a street or regrade it or whatever. They gotta also maintain the volume that's in the right of way, right?
If we rebuilt the street, yeah, we would not be able to raise the profile in any sense.
Right.
Or add a bike path. Without compensatory storage.
Right.
Okay, I'll make that motion.
second,
Okay, all in favor?
Well, just,
Aye.
just again, just to be crystal clear, so the motion is to accept Eric's recommendation to maintain the full floodplain storage district for Esser Pond.
Yes, that's right.
Great.
The blue hatched area. And that's subject to, if Steve's gonna investigate the nuances of this DOT right-of-way area and things like that. I assume.
Yeah.
Yeah.
To be part of.
What we present next, but yes.
Okay, all in favor?
Aye.
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 Opposed? Motion's carried. Next item of business is the flood mapping amendment to Steve's going to present.
Yeah, Steve, you want to just
Sure.
run right into it?
Yeah, Eric.
Asked us to scope out, what it would take and the cost to take these maps through FEMA approval. And as we looked at this, we realized there's so many questions, including the one you were just talking about. Well, what about the DOT right of way? It makes sense to us to take this, to stage this or phase it and have a scoping phase to answer some of these key questions, or to help you on behalf of the city make some decisions about how you want to move forward. And that'll help refine the costs for the rest of the process. But we wanted to lay out our best estimate of what we, based on what we know now and the different components of this that may or may not be included. So you have at least a rough idea, the best idea we can present about the overall cost of this in time frame. But what we're suggesting is take a month or so, $7,000 scope, and dig into some of these questions that have a big impact on kind of the remapping process and the cost. And can run through the details of this first phase, but Eric, you just want to scroll through the first phase would be, let's answer these questions like the one we were just talking about with the DOT right of way. Get answers from DNR. Folks can decide, if you want to talk with neighboring municipalities, and how the maps, whether the maps would extend, across the city line, cooperation with your neighbors. Then the next phase would be actually updating the maps and, the models that support the maps, having a public meeting, getting it to city council approval. That would, depending on the details, we'd estimate a 3 to 6 month process, with a big cost range you can see there, because of, these dangling questions. And then the third phase would then be getting regulatory approval. First Wisconsin DNR and then FEMA. What we've heard from DNR, Chris Olds, the head of their floodplain program, is DNR typically has a 6-month review period. And then FEMA, there's an open question about what process will be required, but based on our experience and feedback from DNR, because this is a big area, this probably would kick into a process that's multiple years, probably a 3-year process, which FEMA calls the physical map revision. And it's something that tends to be the process they follow when a remapping effort spans multiple flood insurance rate map panels. And in this case, this area is on 6 different panels. So it seems almost for sure that this longer, more complex process would need to be followed. And you know, what DNR says is, well, that's typically a 3-year process. That's timing is somewhat of a wild card with FEMA in our experience, but you know, this would certainly be a long haul. Sure, that's not really welcome news, but it's a long-term effort here, but from what we know now. So that's the overview. Being happy to go back through and sort of talk through the details of what we're proposing for this first step. But because, you know, it's worth noting, we're talking about the $7,000 screening phase. Our estimate for the second phase is ranging from, Eric, I think it was $27,000 to pushing 50. I don't think the $50,000 or $49,000 is likely, but if you look at all of the, you could want to do this, or you could have to do that. If you add all those things up, come up with a price tag like that. The goal of phase 1 would be to better define that and steer that toward the low end of that range. And then with the DNR and FEMA remapping process, you know, certainly tens of thousands of dollars. I think the estimate we had in there was about $60,000, again, spread out over 3 to 4 years, based largely on our experience with other FEMA approval processes. But the obviously it's a lot of money. It's spread out over maybe 4 years in this process. The way it typically works with FEMA is they say, yeah, we'll talk to you when you submit something to us. You know, you fill out the forms, submit the forms and the models and the maps. They have 90 days to review it. You know, they get back to you in 3 months. They always have lots of questions and nitpicky comments. You know, you answer those after you refresh your memory of what you did 3 months ago. Send that in, you know, wait again. And so that's kind of the dance that typically goes on. And in this case, it'd be probably for 3 years. So, you know, we're estimating something like 60 hours a year of kind of managing that process. Again, we may well know more as we get through some of these initial phases, but with FEMA, you know, it sounds like from what DNR says, your city's unlikely to get an answer about, is this going to be the 6-month process or the 3-year process until you actually submit the materials to them. Although we can certainly try to talk to FEMA ahead of time, but I think it's a safe bet. It's going to be the physical map revision and the multi-year process. So let me just pause there and see if you have any questions about kind of that big picture that we're forecasting here, or
And
the
I'll
general approach.
interject something right away. You know, I think I threw a dart at a budget for this, and I think I missed the dartboard. I had asked for, I think, $45,000 over a couple of years.
Yes, you did.
When council went through the budget, Lisa, correct me if I'm wrong, you approved 30,000 for this year.
Yep, and 15 for next year.
No, okay. Or that's the plan.
And I'll also note that this project had been taken out of the capital requests for 2023, and I put it back in partly because it was, well, mainly because it was so important to this commission. But the $30,000 cost didn't seem like, you know, something we should put off. If it had been 116 or 124,000, it probably wouldn't have been put back in.
Yeah, and I'm hopeful that Steve is being conservative, but yeah, we're looking at a lot of money spread over the course of 4 years. Probably twice what I had spent.
So
This doesn't
where can the rest come from is what I'm wondering.
It could come from the stormwater utility. It could come from fees in lieu, I believe.
I don't know about that.
Capital borrowing, not fees in lieu, Warren.
I don't think so.
Why not?
Well, fees in lieu are collected money to build if you couldn't meet our standards in one location, then we would use that money to do the same
Compensate.
kind of structure in some other area.
Yeah. Lisa, why would this come out of capital though? I'm curious about that one.
Why did it come out of, or why are we funding it through capital borrowing?
Why would we fund it? Why would the city fund it through a capital?
That's just how a lot of projects are funded.
But this isn't, you're not building anything here, right? There's no capital.
Right, but I mean, we have a lot of plans that we write where we're not really building anything, but that's funded through the capital borrowing.
Wow, I didn't know that. Well, I knew this was gonna, we talked about this months ago, and this doesn't surprise me, the numbers are what they are. And again, I understand the drawbacks of, we can still enforce these districts without the FEMA mapping. It's not gonna be easy.
Yeah. Mhm.
And I'm sure Eric would, and Richard would, it'd be a lot of staff burden, frankly.
Well,
to keep.
I think if phases 1 and 2 can come in at $45,000 over this year and next, we're good. And I would consider the WDNR and FEMA approval process as a different project.
Mm-hmm.
Yeah, I think that's right.
I think the council has to buy into these districts, first of all. I mean, we just voted on these districts tonight, but council may have another opinion on this.
Yeah, keep in mind, we spent over, I don't know, Steve, how much this flood study cost, but over $100,000, right?
That's right, Warren.
So we already have a lot of money invested in this process, and doesn't seem right to stop right now.
And, if you
Don't go through the FEMA approval process, you're not pulling the plug on this effort. You can still use this information.
Right.
As Jim was alluding to, this could be separate from the flood insurance study, and it could be information that's used in the zoning code and provided, through other means to residents of the city in terms of flood information. Obviously, then you've got two sets of floodplain maps, the flood insurance study, which is 20 years old, and then the more updated ones. And you've already sort of talked at past meetings about pros and cons of that, but you can do that. DNR said you can absolutely do that if you want to. Someday DNR may come through and remap this. We haven't asked, they haven't said, well, we're going to do this in 5 years anyway, but I suppose the city could take a waiting approach on that. And again, something we could talk over with the DNR, and you can talk over the DNR. So it's not all or nothing, but
Well, it could be something, I mean, this commission could recommend phase 3 as a project in the budget for 2024. I think that's, if we had to pick an option right now, that's what I would recommend.
Yeah, I like that idea, Lisa. We don't need to commit to all 3 phases tonight, right?
Yep.
Just phase 1, right?
Yep.
Well,
thing I
and
noticed
we do have money in the budget for, again, $30,000 this year and 15 next year. So if it's possible that, well, phase 2 would take it to 34,000 at the low end.
Well, if we ask Steve to move forward with phase 1, then in, let's say, 2 months, maybe March, maybe April, Steve could come back with a more detailed proposal for phase 2 for your review.
That sounds good. I had a question about the Tribeca development, just wondering why that one is referenced so much in here.
Oh, and this maybe
it was before your time in the commission, Lisa. The Tribeca development involved changing the routing of stormwater flows and actually diverted water that used to flow to Graber Pond into Pheasant Branch. And So there was a project in 2021, I believe it was, using the same model to look at the impact of that proposed diversion on Pheasant Branch Creek. So that modeling is done, it's actually changed the flood flows in Pheasant Branch slightly. And so it would make sense to pull that into the model used for the mapping. But yeah, that's why it was a watershed diversion that affected Pheasant Branch.
Okay, thanks.
There was something one of you mentioned that's worth thinking about in the sequence of tasks here, and that's getting city council to buy into the flood storage district. Or maybe the right way is determining what the city council wants to do with them. And right now, the way phase 2 is written is doing the technical analysis, public presentation to council and approval. Maybe there should be a step earlier on, if you think it makes sense, to introduce this concept to the council and make sure that we're not going down the wrong path, then getting to the end and then saying, well, wait a minute.
Yeah.
But what do you think?
Well, that sounds like a good idea.
Step 1 right now, the way it's written, would not include any presentation to city council.
Correct.
Okay. I
So
agree
that'd be part of step 2 then, right, Steve?
Be part of step 2. And
The way we've written it, it's the end of phase 2. And, if you think it's important to get the opinion of council earlier on, we can add that in or shuffle the schedule. I mean, I think at the end, Eric's vision was you want the city council to approve these maps that would then go to the regulatory agencies. So it seems like presenting it to the council at the end is necessary, but
It might be
some
a little
interaction
risky.
with them earlier makes sense.
Yeah, no, Lisa, my thought would be to have it presented earlier rather than later. And yes, they may mean a second presentation if you have for approval, or at least something like that, but I'd like to get their understanding and, comfort level up before bringing it to them as the last step.
Yeah,
I agree. And I also would emphasize the need to make it as non-technical a presentation as possible and really get into
Come
really get
on.
into what does this mean for our constituents?
Yes, that's what they care.
Yeah, I could see them rolling their eyes.
Well, this did all go before council in 2020, right,
oh,
Steve?
yes, summer.
Summer of 2020, summer or spring,
And
but we're coming up on 3 years.
I think the result was, they accepted the study, but then it kind of
Yeah.
is laid dead in the water.
Yeah,
Well, I would definitely reference that they've, 5 of the members would have been on council in 2020. So definitely bring that up in the presentation that they've seen this, many of them have seen this before.
but I would have a hard time believing, because I don't remember all the details, that they'll remember what the implications is what have to certain private landowners along these
Right.
district boundaries.
Right. No, I'd be amazed.
Yeah.
And I guess it's worth noting too, that council meeting was in conjunction with the, I don't know if public hearing is the right term, but it was a public information meeting combined with commission and council, if I'm
To me,
recalling
it-
correctly.
Do we
If this
know what
could work out-
does anyone recall offhand what month that was in 2020? Because that would be a good thing to share with council members in advance. The video.
Steve gave a great presentation. There's video of it. I can send you that meeting date or the link to the
Okay.
YouTube.
Thanks.
And we had the maps out, we had big scale maps up on the walls and stuff. It was,
That's right, city staff did a
Nice printout of comparing the old maps to the new maps.
mhm.
I don't remember a lot of negative comments by the public though.
No, I don't either. And there are probably 30 or 40 people there.
Yeah, I don't. Everybody seemed to buy into it was a good thing to do, or
Yeah,
the right thing to do.
I just have to believe that the impact wasn't as concrete at those discussions as it could be now.
Yeah, that's true.
Agreed.
So anyway, can we approve phase one and maybe phase two if the commission feels that way, with some shuffling of the earlier presentation perhaps? That can get negotiated between Eric and EOR.
You can make that motion, Jim?
Well, I'm in my mind, I want to know, Lisa, you're the finger on the budget. If you think phase two we should set a limit on this so we know what we're dealing with. We can say up to X dollars.
Yeah, I mean, we have up to $30,000 to spend on floodplain mapping in 2023. And 15,000 more in 15,000 more is earmarked in 2024, but that'll have to be approved.
Right.
So the question, Lisa, should we have a motion that includes phase 1 and 2 together, or phase 1 separately?
I would go for phase 1 and 2 in an amount not to exceed $30,000.
Yeah.
That makes sense.
So moved.
Do we
Sorry,
have a
I'm
second?
already 7 minutes late. I told Eric I had to sign off at 8:30. So I want to participate in the vote, but
All
Second.
right.
I'll second.
We got
Okay.
David Shaw seconding, but okay.
Oh,
Either
sorry.
way.
She's
Whatever.
got her coat on.
Next, we're gonna see her in her car.
Okay, all in favor?
Aye.
Aye. Opposed? Motion's carried.
thanks
Thanks,
for all the
Grace.
useful discussion. Really appreciate it. See you next.
Bye, Grace.
Thanks, Grace.
Okay,
And thanks, Steve.
Yeah.
You're welcome. Thank
You and Eric, I guess I'll be in touch and we'll work out the details of this.
Yep, yep.
thanks
Sounds
for
good.
hanging in there, Steve, with all other
You bet.
presentations.
Well, it's always interesting to listen to Todd talk. So it was, I enjoyed it,
Yeah,
but
good.
now I got to go do the equivalent of curling, whatever that is. So take care.
Yeah.
Bye, Steve.
Okay, Lisa, I guess the next one is, you want to lead that on the city of
Yeah,
Middleton
and-
and town of Springfield working
Yes,
group?
and thank you for putting this on the agenda, and I can make this really brief because really what I'm looking for is a volunteer. And maybe now that Grace just left, so I can volunteer Grace, but so the idea is that, you know, the council has met twice now with the supervisors, the town board of supervisors in Springfield. This is part of Alder Fassard's initiative to try to mend fences between our two jurisdictions in the aftermath of the very contentious airport master planning process. And at both meetings, one of the things we talked about is stormwater, joint stormwater management projects. And, as you can imagine with, I don't think of us as politicians, but as, elected officials, we've talked a lot about this now twice. And at the last meeting, Alder Olson, who I can't see if she's still on, but I saw her earlier, she suggested that we organize working groups to take our discussions of this item and other items too, and turn them into some actions that we can bring back to the next committee of the whole meeting with the town. And so Alder Fassard and I are the two who were tasked with being on a work group with the town chair, Jim Pulvermacher, and town supervisor Meinholz, to work out some ideas for concrete steps we can take together to take advantage of the land that is in the town that can help us in the city better manage our stormwater. And so what I would like to do is find one volunteer or two if people are interested. And ideally, we'd be able to come up with a short list of actions that this commission would recommend. And that could be seeking grant funding, working with other partners. It could be, specific ideas for how, we talked a lot about dams and catchments instead of ponds. But to work with the two supervisors from the town and me and Luke Fazard to come up with some recommendations so that at the next committee of the whole meeting, we can actually take action instead of discussing it again. And I'll tell you, we don't have that next committee of the whole meeting scheduled. I think we were trying to do them every 3 or 4 months. There's an election coming up, so that could get in the way. And it's also winter, so maybe trudging around to do like some field trip might not work so well, but we can see. But I would appreciate it if one of the like hardcore water experts on the commission would volunteer to participate in this.
Lisa, are you thinking that staff people would be best not to be on this group, at least as far as official members, but maybe advisory or whatever?
Well, no, I think, I think Eric should be a part of it if his schedule permits. But I also think it would be good to have someone who's on this commission participate. Someone besides me, because I'm not a water expert.
Well, I'll express interest. I don't know if there's others that would like to be on this group too, so.
It sounds good to me, Jim. I wouldn't mind being on it, but I'm pretty much
You've got
have to stay
commitments,
around the
Warren.
home,
Yeah.
so
Yeah.
I really can't do it.
Okay, well, thanks, Jim. What I'll do is I will follow up then with
Wait
you.
a minute. I thought somebody would fight me for this or something. That's it?
Step right in the trap.
You waved your hand, that's enough.
I kept my arms folded here. I'm not waving anything. All right, no, I'd be interested.
Okay, great, thank you. And I'll follow up with you and Eric probably Friday to just, try to get this ball rolling, because I really, as much as I enjoy meeting with our colleagues in the town, it's more satisfying to me if we can come away from a meeting with actual action items like, okay, let's invest in this. So this will be good. Thanks.
Okay.
Yeah, and certainly Eric's going to be involved, right?
Yes.
Okay, it sounds good. Thanks, Lisa. The next item then is items possible for the February meeting.
Yes.
I already talked to Eric about including something on Middleton's ice, salt policy for ice.
Yeah.
And so that's going to be on the agenda. I had read what Madison's doing, and so I thought we should update what our policy in Middleton is. We talked about this a couple of years ago, but I thought we ought to refresh our discussion on it again. So that's one agenda item. And excuse me.
Go ahead, Warren. I'm sorry.
Possibly if there's time and I get a summary of the 2022 data for the 3 gauging stations in Middleton, I'll do that in February, but more than likely it'd be a subsequent March or later meeting. Is there anything else, Lisa, that you had in mind?
Well, in light of the presentation that we saw about phosphorus, it's just, I'm someone who signed up for the Adopt a Drain program. Eric knows this. And I'm out there sweeping up leaves, and then I see that 75% of the phosphorus is coming from agricultural lands, and I'm thinking maybe we should have Adopt a Farm, instead. But the digester, the manure digester was mentioned, and Dick Lathrop and I actually got to go tour the digester. They had a sort of a little gala event, and it was very informative, but we learned that there were only 4 farms that were participating. And, the realization of how many digesters it would take to cover all of the farms that are producing manure in Dane County. It was, it was a little overwhelming, but I'm just wondering if maybe we could get a short presentation from the digester people about what they're doing and any opportunities they might have or be thinking about expanding.
That's a good idea, because Eric and I kind of talked about that yesterday, so that'd
I
be
would-
great.
I hope to learn someday where, I hear all about the reductions, 90% phosphorus reduction. Where do these phosphorus atoms end up? There's some simpler I learned about matter neither being created or destroyed, and the phosphorus goes somewhere. I mean, is it being,
It's
Truck
going
out of the
out of the
watershed?
watershed, Jim.
That's what I was
Goes
wondering.
into-
Out of the watershed.
In the
They're
Black
going
Earth Creek, go Black Earth Creek.
No.
Well, they are trucking the dried, concentrated material into fertilizer factories, right?
Yeah, I think the big thing though, they would apply it to land at a better opportunity instead of on frozen ground.
Yeah,
Yeah.
taking them to the south, yeah.
So
Well,
I
and
think the application would be better, and you wouldn't over fertilize then.
Yeah, hopefully.
Well, it would
Okay.
also be good to learn what we can do, because I took a note that he said something about ordinances regarding spreading of manure in winter. And I worked with legislative group, including Wisconsin. And from what I recall, there was a lot of reluctance to tell farmers how to.
Oh, yeah.
Yeah.
Well, Lisa, regarding the town of Springfield, I'm pretty sure that one of the reasons why the Wagners didn't want to negotiate some of their land being used for a pond of any sort was that they were going to lose the ability to spread manure within the footprint of that pond. It's a valuable thing to have land to spread manure on. And so it's a big deal.
Yeah.
But I like Jim's question because, if it may be that the phosphorus is being taken out of the watershed, but doesn't that just mean it's going into some other watershed?
And you're talking about the digester on Schneider, right?
Yeah. Yep.
Yeah, I toured that quite a few years ago now, but I don't want to say this indelicately. The claim was it was going to a watershed that had a phosphorus deficit. And that was the only details I ever heard at that time. I don't know where that place is.
Can't you bag it up and then sell it to the people in Madison?
That's
It's called Milorganite. Yeah.
You
All
call
right.
it Dane Organite.
Yeah. Yeah.
Is the ordinance right now for your spreading manure, you can't spread it on frozen ground during the winter, or can you do it?
There's the only ordinances I'm aware of are all tied to being part of a cost sharing program or receiving federal money. I don't believe, again, I may be wrong. I don't believe there are any, just outright ordinances in townships or counties or cities that regulate that.
I think you're right.
Yeah, I'm not aware of any, but you know what? I'll follow up with this Great Lakes group that I used to work with. Senator Andre Jacques is the chair of it now, and so I can follow up with him and find out because he actually chaired the nutrient management task force that we had. So I have a reason to call him anyway. So now I'll add this to the list and I'll see what I can report back next time.
All right.
As Todd pointed out, it's spreading the manure during the winter period with the snow melt is when the problem occurs.
Right.
Yeah. On a different topic, I know we're getting late here. I hope I'm being transparent here. I'm on the Friends of Pheasant Branch Watershed Committee. And as Eric knows, and probably other people know, they're very, very in tune and interested and concerned about the developments north of Graber and Red Tail and up in that area. And so I know they want to keep tabs on as we move along with that. Now, to my knowledge, Bell Farm has not come in for a final stormwater management plan review and approval. Is that right?
They're still working on it. That's correct, Jim. But honestly, with that one, I don't know if I was planning on bringing it back to you. If you want to, I certainly will.
I think we ought to, only because of the amount of attention it's getting.
Yeah, I think so.
We had asked for 100% infiltration and distributed practices. I guess we can't go into this that much.
No, I don't. Well, you're right.
But they were providing those. There's been, several kind of hiccups as they've been moving through the process. And right now, there's some environmental concerns at the south end of that land, the old quarry and landfill site. And we're waiting on answers for that because that's kind of a portion of that was part of where they were getting a lot of infiltration.
Mhm.
Yeah.
Is
But
this,
anyway, I know that it's not gonna go away. And it shouldn't. And we should pay special attention, or at least due attention to both those developments.
I would agree. They're both going to be in District 6. So thanks for bringing that up, Jim.
yeah. I was wondering if the higher interest rates are slowing down those developments.
Yeah.
Certainly the time they were proposed, they're talking 1 or 2% loans, and now you're talking what, 6%?
Yeah, I don't know. Bell Farm I think they're coming in with a smaller phase one essentially. And my guess is they need to get something off the ground in the near future or risk failure. This has been dragging on for quite a while.
Yeah. Okay,
Okay,
so if there's nothing else for the next meeting, the meeting's adjourned.
Right.
we
Thank
don't
you.
we don't vote on this one, huh? The
Nope.
utility board had a
Meeting's
vote.
adjourned.
Thank you, everybody.
Okay.
I gotta learn from Warren. Okay.
Yeah. All right. Bye-bye.
Thanks, everybody.
Good night.
How do I get out of here?
Didn't take as much time as I thought, so
Well, that was a long one.
yeah. Well, Miller